In this episode of Cosmos, we'll delve into the fascinating story of Earth's formation, exploring its origin and the processes that shaped it into the planet we know today. Learn about Earth's physical characteristics, including its rotation, orbit, and chemical composition. Journey deep into Earth's interior to uncover its structure and the geodynamo that gives rise to the planet's magnetic field. Explore the layers of the atmosphere and gain insight into the unique features of its landscape. Witness the breathtaking beauty of its surface from the board of the International Space Station and immerse yourself in the wonder of our planet's remarkable complexity. Sit back, relax, and enjoy the show. Planet Earth. A tiny dot in the vast cosmos, home to millions of species of living organisms, the cradle of human civilization. Earth is the third planet in the solar system and was formed about 4.5 billion years ago. It was created from the condensation of an interstellar gas cloud, from which the Sun and all other planets originated. Earth is located about 150 million kilometers from our star, equivalent to 1 astronomical unit. It falls within the so-called habitable zone, between the orbits of Venus and Mars, where it is possible to have liquid water, one of the necessary conditions for the existence of life. 71% of Earth's surface is covered by water, while the remaining 29% is landmass, consisting of continents and islands. They have emerged as a result of the movement of individual tectonic plates, which are part of the Earth's crust. It is a little-known fact that since early antiquity or around the 5th century BC, people hypothesized that the Earth is spherical in shape. Today, we know that it actually resembles an ellipsoid, as the poles are closer to its center than its equatorial regions. The difference between the polar and equatorial radius is small, on the order of 21 kilometers. Among all the terrestrial planets in the solar system, Earth is the largest and densest body. Its circumference is approximately 40,000 kilometers along the equator. Viewed from the celestial North Pole, the Earth rotates on its axis counterclockwise, which we call direct or prograde motion. That is a common characteristic of most planets in our system, except for Venus and Uranus, and is due to the specific motion of the primordial gas cloud. That is why the Sun's axial rotation, as well as the orbital motions of most bodies in the solar system, are also in a prograde direction. The rotation period of the Earth lasts approximately 23 hours and 56 minutes, but relative to the apparent position of the Sun it equals exactly 24 hours. One orbit around our star takes 365 days and 6 hours, hence we count a leap year every 4 years. Earth's axis is tilted at 23.4 degrees, leading to uneven heating of its surface and the existence of seasons. You're probably wondering, what causes this tilt? The prevailing theory suggests a collision with another planet, occurring only about 100 million years after Earth's formation. It is assumed that the impacting body had approximately 10% of Earth's mass and the size of present-day Mars. The object in question is named Theia, and the debris from that powerful collision formed the Moon. Our natural satellite is roughly 4 times smaller than the Earth and is located at an average distance of 380,000 kilometers. In the solar system, the Moon is the largest satellite relative to the planet it orbits. The gravitational force of the Moon stabilizes the axial tilt of the Earth and thus regulates the climate of our planet. Existence of tides in Earth's oceans and seas is also due to the Moon's gravitational pull. The abundance of liquid water on the surface is a unique characteristic of Earth that makes it distinguishable from the other bodies in the solar system. The totality of all water basins is called a hydrosphere, consisting of oceans, seas, rivers, lakes, and glaciers, as well as groundwater found at depths of up to several kilometers. If we assume that our planet is a perfect sphere, with no variations in the topography of its crust, the depth of the world ocean would be less than 3 kilometers. The majority of the hydrosphere is in the form of saltwater, with freshwater reserves accounting for only 2.5% of the total volume. Over 2/3 of freshwater is frozen in glaciers and ice caps, making it an extremely limited resource. The origin of dissolved salts in the world's oceans is directly related to rock erosion and volcanic activity on the planet. Oceans are fundamental to the emergence of living organisms, as they provide a nutrient-rich environment. Besides absorbing large amounts of gases from the atmosphere, such as nitrogen, oxygen, and carbon dioxide, they also act as reservoirs for the incoming heat from the sun. Atmospheric and oceanic currents are accountable for distributing surface temperature variations and therefore regulating the global climate. Climate is the set of meteorological elements that characterize the atmosphere of a planet. The Earth's atmosphere is a thin shell of gas that extends up to about 500 kilometers above sea level. The density of the atmosphere progressively decreases with altitude. It is suitable for life only in the first 7 to 8 kilometers, where most of its mass is concentrated. That layer is extremely thin and equals only 1/1000th of the planet's radius. If you are enjoying this video, give it a thumbs up and share it with your friends. Subscribe to the channel and hit the bell button to be notified of new episodes. You're welcome to post questions, thoughts, and recommendations in the comment section below. If you value our work and like to support it, please consider donating and visit our Patreon page. Join us on social media to stay updated with the latest space news and short clips on upcoming topics. Keep watching Cosmos to learn more. Earth's atmosphere is composed of 78% nitrogen, 21% oxygen, and a small amount of argon. The content of other components is extremely low and has a variable concentration. Among them are water vapor, ozone, carbon dioxide, dust, and other gases. The amount of water vapor can vary widely and is responsible for cloud formation. At any given moment, 2/3 of our planet is covered by clouds. The presence of the ozone layer is of exceptional importance, as it protects living organisms from the deadly ultraviolet rays of the sun. Another major function of the atmosphere is to maintain the greenhouse effect. It limits the heat loss into space and provides an average surface temperature of about 15 degrees Celsius. Without the greenhouse effect, the average temperature on Earth would be around -18 degrees Celsius. In the vertical direction, the atmosphere is divided into 5 temperature layers: troposphere, stratosphere, mesosphere, thermosphere, and exosphere. The troposphere begins at the Earth's surface, extending to a height of at least 10 kilometers. Cloud formation occurs in this layer, as well as atmospheric phenomena such as wind, rain, and snow. As we ascend through the troposphere, the temperature gradually decreases, reaching as low as -60 degrees Celsius. From an altitude of 10 to about 50 kilometers extends the stratosphere, which contains the ozone layer. The absorption of ultraviolet rays by ozone molecules releases a lot of heat. That leads to the warming of the stratosphere, and the temperature in its uppermost part reaches around 0 degrees Celsius. Due to its lower density, the stratosphere is used for flights of supersonic aircraft. The mesosphere is situated at an altitude of 50 to 85 kilometers. It is the coldest layer of the atmosphere, with an average temperature of -90 degrees Celsius. The so-called shooting stars are observed precisely here. They are meteors with sizes of a few millimeters that enter and burn up in the atmosphere. The thermosphere is the hottest atmospheric layer located between 85 and 500 kilometers. The absorption of ultraviolet radiation by hydrogen atoms raises its temperature above 2000 degrees Celsius. The International Space Station orbits in the thermosphere at an altitude of about 400 kilometers. Polar auroras form in the ionosphere, which is also part of the thermosphere. The exosphere is the outermost layer of the atmosphere, extending from 500 to about 10,000 kilometers, with temperatures exceeding 1000 degrees Celsius. It is composed mainly of hydrogen and helium ions but has an extremely low density. Because of the low atmospheric drag, the orbits of satellites in the exosphere remain stable for extended periods. From 600 to about 60,000 kilometers from the surface, we find the radiation belts of the planet. They protect the atmosphere from solar wind and cosmic rays and exist thanks to the magnetic field generated within the Earth's core. The surface of the Earth has an area of approximately 500 million square kilometers. It consists of oceans, seas, continents, and islands. The world ocean is divided into 5 oceans, while the continental landmass separates into 7 continents. 250 million years ago, all the land on Earth was concentrated in one continent called Pangaea. 120 million years later, Pangaea split into 2 parts at the equator to form the continents of Laurasia and Gondwana. Over time, their fragmentation continued and led to the formation of the 7 continents we know today. Along the periphery of the continental plates lies a vast seafloor mountain system. It is called the Mid-Ocean Ridge and is the longest mountain range on the planet, stretching for 80,000 kilometers. The average land elevation is about 800 meters above sea level. The lowest point is located in the area of the Dead Sea in the Middle East, situated at 430 meters below sea level. The highest peak is Mount Everest in the Himalayas, reaching a height of 8,848 meters. Interestingly, Mount Everest is not the most distant point from the center of the Earth. Due to the irregular shape of the planet, the most distant one is Mount Chimborazo in Ecuador. Closest to the planet's center is the Mariana Trench, with a depth of 11,022 meters below sea level. The layers in the structure of the Earth differ in their chemical composition and density. They extend from the surface to the inner core of the planet. The average distance to the center of the Earth corresponds to the planet's radius, which has a length of 6,371 kilometers. As we go deeper into the Earth, we observe a gradual increase in density, temperature, and pressure. Our planet is composed of 3 main layers: crust, mantle, and core. Earth's crust is the thinnest outermost layer, with a depth between 5 and 40 kilometers. Beneath major mountain ranges, the continental crust reaches up to 70 kilometers, while the oceanic crust does not exceed 15 kilometers. The crust contains mostly iron, oxygen, magnesium, and silicon. Earth's crust, along with the upper part of the mantle, is called a lithosphere. Movements of the lithosphere over the fluid layer in the mantle form the planet's tectonic plates. They are responsible not only for the formation of the continents but also for the volcanic and seismic activity of the Earth. The thickest and most massive layer is Earth's mantle. It is located beneath the crust and has a thickness of 2,900 kilometers. In its upper part, the mantle is composed of solid rock. The temperature there is around 500 degrees Celsius, and at depths below 700 kilometers, it exceeds 1,300 degrees Celsius. Rocks in the lower part of the mantle are molten and are called magma. With increasing pressure in the mantle, magma reaches the surface and triggers volcanic eruptions. At a depth of about 3,000 kilometers begins the core of the planet. It has a radius of 3,500 kilometers and is slightly larger than the planet Mars. The core is composed of iron and nickel, with small amounts of various silicates. The temperature of the core ranges from 4,400 to 6,000 degrees Celsius. In its structure, we distinguish an inner and an outer core. The inner core is solid, while the outer core is in a liquid state. The hotter inner core transfers heat to the outer core, generating electrically conductive flows within it. Due to the Earth's rotation, these currents form magnetic field lines, which create the planet's magnetic field. This phenomenon was discovered over 1,000 years ago with the invention of the compass. The geomagnetic field resembles the field of a natural magnet, with its field lines passing through all layers of the Earth. Magnetic poles are located near the geographic poles, and the magnetic axis forms an angle of about 11 degrees with the planet's rotational axis. Currently, the North Magnetic Pole is in Antarctica, while the South Magnetic Pole is situated in northwestern Canada. Over time, there has been a noticeable movement of the magnetic poles, which has been particularly active in recent decades. The two poles move independently of one another, with these displacements reaching up to 40 kilometers per year. The intensity of the Earth's magnetic field varies in different parts of the planet. It is highest near the poles and weakest around the magnetic equator. There are also some significant anomalies found in eastern Siberia and the South Atlantic Ocean. The strength of the magnetic field is gradually changing, and over the last 200 years, it has decreased by about 9%. That is due to the chaotic nature of the convective processes in the outer core, which can lead to a shift of the magnetic poles. Geological studies have revealed that these poles swap places several times every 1 million years, and the last reversal occurred about 700,000 years ago. Earth's magnetosphere is composed of the geomagnetic field, the ionosphere, and the radiation belts. It shields the planet by trapping electrically charged particles with high energy. Their origins are related to solar activity and other sources from deep space. The magnetosphere forms rings up to a distance of 10 Earth radii in the direction of the Sun and a long tail on the opposite side of the planet. During increased solar activity, particles captured by the magnetic field lines of the magnetosphere are directed from its tail toward the polar regions. Their interactions with gases in the ionosphere create the optical phenomenon known as aurora or polar lights. The combination of specific characteristics of the Earth makes it the only body in the solar system known to support life. Further study of our planet is necessary to preserve the favorable climatic conditions and its unique biosphere. It is humanity's duty to protect our tiny home in the great cosmos.